All right, so we're back for another lecture video. Fifth period today, they have the option. Hey, I'll either give you a lecture in person, which is nice because I don't have to make videos, which take me several hours. But virtually everybody voted for the video. I think like two people raised their hand for in person. So here we go. Now remember, if you're not really watching, if you're just letting this play in the background, it's not just going to seep through your head and you're going to understand it. You have to actually watch. You're going to have to take some notes. You have to do some thinking. All right, here we go. All right, so chemical bonds and valence electrons. What is a chemical bond? Whenever you're bonding something together, you're holding something together. So it's a force that holds two or more atoms together. So you can see it right here. Here's a classic water, H2O. H2 means it has two hydrogens. O means it has an oxygen. So why are these guys bonding together to form water? Why doesn't hydrogen stay as hydrogen by itself and oxygen just stay alone as oxygen? Well, atoms form bonds to become more stable, usually by achieving a full outer shell of electrons. Remember, that's called your valence electrons. So this right here with water, this is a covalent bond, which I'm not going to go over today, but we will go over later. So oxygen has its six valence electrons. It wants eight. If it gets eight, it'll be full. Hydrogen, each of these hydrogen has one. And remember that inner shell right here has one, two. So hydrogen just needs one more. It needs two in order for it to be full. Well, they're sharing electrons here in a covalent bond. And in this, it's going to make oxygen fill its outer shell with eight. And since it's hydrogen is sharing with oxygen, it's going to fill hydrogen's outer shell with two. So it makes all three atoms stable. So this is why atoms form chemical bonds, in this case, making a water molecule. All right, so what are valence electrons? We've gone over it before. These are the outermost energy level electrons of an atom. It got cut off a little here. So it's the electrons in the outermost energy level. So you can see carbon here. Here's its valence electrons. One, two, three, and four. So carbon's got four valence electrons. So these two in the inner shell are not valence electrons. It's just its electrons in its outermost shell. So these are the electrons that are involved in bonding between atoms. So it's not these inner core electrons. It's the electrons in the outer shell. These are the ones that are going to form the chemical bonds. These are the ones that are going to determine the chemical reactivity of the element. So it's the number of valence electrons that determines how an atom will bond and what type of bond it will form. All right, a couple questions, see if you're paying attention. How many valence electrons does oxygen have? Oxygen is right here in group 16. And question 2 says, how many valence electrons does helium have? Helium here is one of the noble gases in group 18. All right, let's see if you get it right. All right, so question 1 was how many would oxygen have? All right, so we got to remember group 1 elements right here, the alkali metals, have 1 valence electrons. The alkali earth metals have 2. We skip all these transition metals because they're kind of weird. We'll get to those later. Group 13 will have 3 borons group. Carbon's group's going to have 4. You see a pattern going here? Nitrogen's group's going to have 5. Here's the answer. Oxygen's group will have 6. It wants to get 2 more in order to fill its outer shell, its valence electrons with 8. Fluorine only needs 1 more. Fluorine and chlorine, the rest of the halogen, these are the halogens. And the other question was how many does helium have? It's kind of a trick question. Most of these guys, like neon, argon, krypton, they all have 8. Unfortunately, do you remember that first shell of electrons only holds 2? So helium's got 2. It's a noble gas. It does not want any more because that first shell of electron only holds 2. The rest of these noble gases, their outer shell holds 8. So the answer was 6 for oxygen, 2 for helium. The rest of the noble gases have 8. And remember, all these guys, carbon, silicon, phosphorus, sulfur, they all want to move over. They all want to get an electron configuration or an outer shell filled with electrons, just like the noble gases here on the far right. All right, something called electron dot diagrams, or also called Lewis dot diagrams. It shows only an atom's valence electrons as dots around the element symbol. So it's the valence electrons that matter. That's what determines. So right here, the number of valence electrons determine how an atom will bond and how it reacts. So it determines its chemical reactivity. So you just look at it. So each dot represents one valence electron. So hydrogen here has one dot because it has one valence electron. Same with lithium. So beryllium has two dots because it has two valence electrons. And you can see over here the noble gases, helium, remember its outer shell, it's only got one shell of electrons, and that first shell only holds two, so it's full with two. And you see neon here, it's got a full outer shell of one, two, three, four, five, six, seven, eight. All right, so the noble gases, helium holds two because the first shell only holds two, but then the next shell holds eight. So neon and argon and the rest of the noble gases will be totally full with eight. You can see fluorine here with seven. All right, so that's the electron dot or Lewis dot diagrams. All right, so we got our next question. Now, if we'd have done this in class on Pear Deck, you were actually going to draw the Lewis dot or electron dot diagram for calcium here. But let's see, you're going to choose a multiple choice. Which one do you think is the electron dot or Lewis dot diagram for calcium? All right, so let's see if you got it right. So first you got to find calcium here in the periodic table. It's located right here in group 2. You can see it's right underneath magnesium right here. There's your calcium. Since it's in group 2, let me make this a little bigger so you can make the dots a little bigger. It's electron dot or Lewis dot diagram. It has two valence electrons. Boink, boink. There's your electron dot or Lewis dot diagram for calcium. It shows you how many valence electrons calcium has. All right, so now reactivity. An atom's reactivity depends on how close it is to having a full outer shell of electrons. How close is it? So all atoms want to fill their outer shell of electrons because if the outer shell of electrons is not full, the atom is unstable. So what can it do to fill its outer shell to become stable? Well, one way is to gain electrons. If it doesn't have enough electrons, like say chlorine or fluorine that have 7, if they gain one more, they'll have 8. That's full. Then you have your other ones like sodium. It has one valence electrons. It's not gonna gain 7. But if it loses that one, its next shell of electrons is full. It'll now be stable. And in covalent bonds, as we saw earlier with water, the atoms can actually share electrons to fill their outer shell. All right, so like group 1, they're called the alkali metals. They're very, very reactive because they're very, very close to filling their outer shell. They have one valence electron. If they can lose that one valence electron, their next shell will be filled and they'll be stable. So they're very, very reactive. The very next group, group 2, the alkali earth metals, they have two valence electrons. So they're still reactive, but they're not as close. They're not as close to the group 1 because they have to lose two atoms. So they're not as reactive as group 1. And then you have on the other side of the periodic table the halogens, the ones right next to the noble gases, not the very far right, but the ones just over. They have 7 valence electrons. They want 8. They only need one more. Once again, that is very close to being filled with 8. So they're very, very reactive. They're going to react with several different other types of atoms. So because you can easily gain one electron. And remember, the noble gases, other than helium, they're all totally stable because they have 8 valence electrons. Remember, helium only has 2 because the inner shell only holds 2. So the noble gases are all stable. They do not react. They do not form compounds. They're happy just being by themselves. But all the other atoms, they all want to get over there by the noble gases. And they do that by filling their outer shell of electrons by either gaining, losing, or sharing electrons. All right, it's going to be a question I was going to ask you in our pair deck, but since we're doing a video to save time, I'm just going to give you the answer, but you can think about it. Which of these groups will be the most reactive? And this might be a question on our test. I'm giving you the answer right here, so this could be easily a question on our test. All right, so group 1, hydrogen and lithium's group with their one valence electron. Group 2, beryllium's group with its two valence electron. Group 14, carbon's group with their four valence electrons, or group 15, nitrogen's group with its five valence electrons. All right, think about it. Now remember, an element's chemical reactivity is determined on how close it is to achieving a full outer shell. Now, which one of these four is the closest? And the answer is right here. It's going to be your group 1, the alkali metals, because they only have one valence electron. Take sodium, for example. It's got one. But if it gets rid of that one valence electron, now it's going to fall down to the next shell. It's going to have the same outer shell as neon does. Because if it loses its one outer electron, the very next energy level of electrons is totally filled. So sodium, these guys right here would be the most reactive because they are the closest to achieving a full outer shell of electrons. All right, positive ion formation. Positive ion formation. A positive ion is called a cation. You will not remember that from hearing it once. You'll need to practice it to remember that a positive ion is a cation. So these are formed when atoms lose one or more of their valence electrons. So if they lose an electron, they're now going to have more positively charged protons than they do negatively charged electrons. And that's going to give them a positive charge. So these usually occur in metals because metals usually have very few, one, two, maybe three valence electrons for the most part. Transition metals can be a little different. So they like to get rid of their electrons. That's what makes them good conductors of electricity. But anyways, so an example is sodium. You can see it right here. Sodium's got 11 protons, and you can see right here it's 11 electrons, 2 in the inner shell. Then you got 8 in the second shell, and then you have its one valence electron right there. So sodium, it's a metal, would love to get rid of that because look, if it gets rid of this one lone electron in its outer shell, the next shell is totally filled. So that's what happens. When it comes in contact with another element in a chemical bond or a chemical reaction, it's going to lose that outer shell electron. And when it does, you can see it's going to drop down, and now sodium's going to be totally stable because its outer shell, its valence electrons, is going to be filled with 8. But remember, since it started with 11 protons and 11 electrons, since it lost one electron, it still has 11 protons, but now it only has 10 electrons. That's what it's going to give it a positive 1 charge. Now you don't write a 1, you just write a plus for positive 1. Now, for magnesium, it's the same thing, but magnesium isn't in group 1 like sodium with one valence electron. Magnesium has two valence electrons, so I'll just do a little red dot. So this would be like magnesium. It has two valence electrons. So it has two of them to lose in order to become stable. So when it becomes ionized, it's going to lose both of them. So when it loses its two electrons, now it's going to have two more protons than electrons. And you can see right here, the ionized version, the magnesium ion, is going to have a 2 plus charge. It's going to have a charge of plus 2. All right, so atoms lose electrons in order to achieve a full outer shell of valence electrons, which makes them more stable. And since whenever you're losing electrons, you're going to have a positive charge. And remember, the number of electrons lost is going to equal the ion's charge. So sodium only loses one. It's going to have a plus, plus 1 charge. Magnesium in group 2, it needs two. It needs to lose two valence electrons. So that's going to give it a positive 2 charge. All right, so the other type of ion, not cations, but anions. A negative ion is called an anion. Won't remember it from hearing it once. Need to practice it. All right, so these are formed obviously when an atom gains one or more electrons. Because if you're gaining electrons, you're now going to have more negatively charged electrons than positively charged protons. And that's going to give you a negative charge. These usually occur in nonmetals. Those are the group of elements that are in the right side of the periodic table, the top right up there. So the noble gases, their outer valence electrons is filled. The ones next to those are the nonmetals. So they're close. They need like one, two, maybe three in order to move to the noble gases to fill their outer shell. So one example is chlorine. So we got chlorine right here. So it's got its valence electrons, always the outer shell. He's got 7. 1, 2, 3, 4, 5, 6, 7. It needs 8 to be filled. It only needs one more. That's what makes it highly, highly reactive because it's so close to becoming stable. It just needs one more. So if it gets around another atom and they chemically react, it can steal an electron from another atom, especially from a metal, because metals love to give up their electrons as it is. So, anyways, so when it gains an electron, you can see it right here in green. So now it's got 1, 2, 3, 4, 5, 6, 7, 8. Boom. It's now a stable ion. But look what it's not a chlorine ion, it's a chloride. So whenever it's an anion, it's going to end with the letters IDE. So if it's an oxygen ion, oxide. Fluorine ion, fluoride. All right, but look at this. So chlorine, it had 7. It only needs 1. It only needs to gain 1 electron in order to be stable with 8. So that's why it's Cl minus. That minus just means like -1. Its charge is -1. Now, oxygen, on the other hand, it's a group 16 element. It's got 6 valence electrons, so it needs 2 in order to become stable with 8. So it needs to gain 2 electrons. So when oxygen steals 2 electrons from another atom, it's going to have a charge of -2. And you write it like that, O2 minus. So oxygen ions, oxide ions, will have a -2 charge. And once again, atoms gain electrons to fill their outer shell and become stable. And that's what all atoms and all elements are trying to do. Following what's called the octet rule, I haven't mentioned it. Octet rule means that most atoms want octagon has 8 sides. Octet, most atoms want to have 8 electrons in their outer shell because 8 will make them full. Remember, other than helium, because that first shell only holds 1, 2. All right, so now we know what ions are. They have to go with ionic bonds. Ions, ionic. All right, so these are formed when a metal transfers 1 or more electrons to a nonmetal. So these are formed between metals, which love to give away electrons, and they give them to nonmetals, which love to take electrons. All right, so the metals lose electrons, forming positively charged cations. The nonmetals are going to gain electrons, forming negatively charged anions. And remember, electrostatic force, which just means opposite charges attract. So the negative anion will be attractive to the positive cation. So you can see it down here. So you have a metal transferring its 1 valence electron to this nonmetal, which is then going to fill its outer shell. 1, 2, 3, 4, 5, 6, 7, 8. So then this metal here is going to now have a positive charge because it lost an electron. And then this element B, whatever it is, since it gained an electron from A, it's now going to have a negative charge. And the opposite are going to attract, and A and B are going to bond together in an ionic bond. Okay, so now a couple examples of ionic bonds. I ain't gonna worry about the words over here. I don't really like them. I like the picture better. All right, so we have sodium here with its 1 valence electron. It wants to get rid of it because the next shell down will be filled. It'll make it stable. Chlorine here has 7 valence electrons. It's only 1 away from having a full outer shell. So it's highly reactive. Both these are highly reactive. Sodium just needs to lose 1. Chlorine just needs to gain 1. So what happens is sodium, when these guys come together, sodium's going to transfer its 1 valence electron to chlorine. Chlorine's going to be more than happy to take it. So then once that happens, the next level, the next energy level, the next electron shell for sodium is going to be filled. And now chlorine, since took the 1 valence electron from sodium, now it has 8. So now it's stable with a full outer shell of 8 valence electrons. So sodium, since it gave up one of its electrons, it now has 1 more proton than it does electrons. So it's going to have a positive charge. Chlorine, since it stole an electron from sodium, it's now going to have 1 more electron than it does protons because the number of protons don't change. It just added 1 electron. So it's now going to have a negative charge. It's going to be an anion, a chloride ion. So we should know by now, opposites attract. So the positive sodium, the negative chloride ion, they're going to bond together, making an ionic bond. Opposites, positive, negative, bond together, ionic bond. Now, on Thursday, we're supposed to do this, the magnesium oxide. So magnesium isn't a group 1 element like sodium. Sodium has 1 valence electron, and only has 1 to lose. That's why it's highly reactive. Magnesium's not as reactive as sodium because it has 2 valence electrons. It's harder to lose 2 than it is 1. But when magnesium does lose its 2 valence electrons to become stable, it's going to have a positive 2 charge, not just a positive charge like sodium. Oxygen is a group 16, so it needs to get 1, 2. It needs to gain 2 electrons in order to become stable to have 8. So that's why when oxygen makes an oxide ion, it's going to have a negative 2 charge. All right, so some properties of ionic compounds. I don't know if you'll need to know this. They form what's called crystal lattices. So it's like an arrangement. So you can see, so you have the sodium ion here and then chlorine, sodium, chlorine, sodium, chlorine, sodium. So it makes like a regular pattern of the elements. So all the sodium ions are going to be surrounded by chlorine ions, and all the chlorine ions are going to be surrounded by sodium ions. They have high melting points because ionic bonds are very, very strong. So it's hard for them. They don't melt very easily under high temperature, and they do conduct electricity very well when dissolved in water. All right, so that is an ionic bond. Only one more slide.